Welcome, this is Coach Dorf. We're in section 4.1 and we're looking at this homework example. In this example, we're supposed to find the absolute maximum and minimum values of a given function on a certain interval. All right, to do this, the first thing we will do is find the critical numbers of our function. The critical numbers are where the function, the derivative of the function equals 0, or the derivative of the function does not exist. Then we'll take those critical numbers, evaluate the function at those critical numbers, and we'll evaluate the function at the endpoints of the interval. Whichever then gives us the largest numbers, those are the absolute maximum values, and whatever gives us the smallest are the absolute minimum values. All right, so in this case, we have the function f of x equals 1/2 cosine of 2x plus sine of x. So let's take the derivative of this. All right, so I have the derivative of 1/2 cosine 2x. So that's going to be 1/2. Now the derivative of cosine is negative sine of 2x. And by the chain rule, I have to take the derivative of what's inside the parentheses there. That's the derivative of the 2x. Okay, and then I have the derivative of sine x, which is just cosine x. All right, so then I've got negative 1/2 sine of 2x. The derivative of 2x is 2. And so I notice that my 2 and my 1/2 cancel out. And so I end up with negative sine of 2x plus cosine of x there. All right. Now, does the derivative not exist at anywhere? No, these are trig functions with sine and cosine. They're perfectly fine. I don't have anything in the denominator because I don't have any fractions here with x's in them. And I don't have any square roots or even roots of anything, and I don't have any log functions. So the derivative exists everywhere. So all I need to look at then is where does this derivative equal 0? And that will give me the critical numbers. All right, well, I look at this and I'm like, it's kind of hard to do this, to figure out where this equals 0. But I'm going to use a trig identity. Okay, and the trig identity is that the sine of 2x equals 2 sine x cosine x. So we're going to use that one here. So I have the derivative equals negative sine 2x plus cosine x. And I'm going to substitute in that trig identity, and that's going to give me minus 2 sine x cosine x plus a cosine x. Now, why is that useful to do? Well, now I see that both of my terms have a cosine x, so I'm going to factor out that cosine x. And then I'm left with a minus 2 sine x plus 1 equals 0. And I have two things that are multiplied together that equal 0. That's really useful in trying to find out when the term equals 0, because either the first thing equals 0 or the second thing equals 0. That's why we always like to factor these types of things together. So cosine x equals 0. When does that occur? On the interval from 0 to pi over 2, because that's what we're looking at. Well, cosine, let's draw my circle here. Cosine equals 0 right there. That's where cosine equals 0, and that's pi over 2. Okay, so that means then that x equals pi over 2. That's going to be one of our critical numbers, because that's where the derivative equals 0. Okay, but I have a second term here. We just did this. Now we need to do this term here. When does that equal 0? So that's negative 2 sine x plus 1 equals 0 on the interval from 0 to pi over 2. Going back to black here, that means if I bring the 1 over to the other side by subtracting 1 and then dividing by negative 2, I get the sine of x equals 1/2 on the interval from 0 to pi over 2. when does the sine of x equal 1/2? Well, that occurs right here. This value right there. There we get the sine of pi over 6 equals 1/2. So I have x equals pi over 6 is a critical number. So in summary here, we have critical numbers are x equals pi over 6 and pi over 2. And we have the interval is 0 and pi over 2. So we're going to look at, so we look at f of x at x equals 0, pi over 6, and pi over 2. That gives me all the numbers that are the critical numbers and the endpoints of the interval. Notice that one of the critical numbers, pi over 2, is the same as an endpoint of the interval, pi over 2. We don't have to repeat that. We just can do it one time. So now I'm going to look at this, at these values, f of 0. And so let's see, you want to put 0 in. Let's see, let me just recall that my original function, rewrite my original function first. My original function, f of x, is 1/2 cosine of 2x plus sine of x. So first we'll look at f of 0. So I'll put 0 in for x there, and I get 1/2 cosine of 0 plus sine of 0. And that's 1/2 times, the cosine of 0 is 1, the sine of 0 is 0, and so I get 1/2 for that. The second one, we'll look at f of pi over 6. So I have 1/2 cosine of 2 times pi over 6 plus the sine of pi over 6. Well, let's see, so that's the 1/2 cosine of pi over 3, because it's 2 times pi over 6, plus the sine of pi over 6. And let's see, the cosine of pi over 3 is the value of 1/2, and the sine of pi over 6 is 1/2. And so I get 1/2 times 1/2, that's 1/4, plus 1/2, that is 3/4. Okay, and then the last one we have f of pi over 2. Okay, again, we are, well, I'll just continue this and go back to that. So we have 1/2 cosine of 2 times pi over 2 plus sine of pi over 2. So that's 1/2 cosine of pi plus sine of pi over 2. And cosine of pi is -1. Sine of pi over 2 is 1. So we get -1/2 plus 1, which is 1/2. Okay, so we've used all three of our points we're looking at, and we evaluated the function at all three of those, and we ended up here with the values of 1/2, 3/4, and 1/2. So that tells me then that the absolute max value of the function on the interval from 0 to pi over 2 is 3/4, because 3/4 is the largest number in the green box. And that occurs at x equals pi over 6. And the absolute min value is 1/2, because that's the smallest number in the green box. It's repeated twice, okay, but it's still the smallest. And we'll put down, that happens at x equals 0 and x equals pi over 2. All right, and remember the absolute max value and absolute min values are the y values. So those are the things in the green boxes, while they occur at the x values like pi over 6 and x equals 0 and pi over 2. Hope that helps.